Hello friends. So this problem is about breaking of a block on a rough ground. So it says figure shows two blocks A and B, each of mass 2 kg, and these blocks are connected to ends of an ideal spring having force constant K, which is equals to 1000 Newton per meter. The system of these blocks is placed on a rough floor having friction coefficient mu is equals to 0.5. Block B is pressed towards the left and released. We have to find the initial compression of the spring so that block A breaks off from the ball during its motion. So what we have? We have two blocks. This is block A and block B, and these two blocks are connected by a string. And the spring constant, this is not a string, it's a spring constant is given, and in this case K, and the value is 1000 Newton per meter. So let us see what are the things that is given. So we have been given a spring constant and which is equals to 1000 Newton per meter, and we have been given mass of A and mass of B. Both are basically equal, so both blocks are having same mass, and this mass is equals to 2 kg. And the ground is not a smooth, it has a friction coefficient, and mu is equals to 0.5. So you have to press this block with some amount so that finally this blocks leaves the wall. So let us try to analyze this situation. What is happening here? So this is the ground surface, and this is one mass, and this is another mass. Now this is the initial situation. Now what you have done, on this side you have the wall. So this is the wall this side. So basically you have compressed this block this side. So this is A and this is B. So let us say you have compressed to this position. So now the situation will be something like this. So this block has a compressed situation and this has reached here, and this block will remain as it is, and the spring has compressed. Let us say this compression is X amount. So X is the compression. Now once you compress this and there is a wall, so this wall is there. So once you compress this and leave this, what will happen? This block has a tendency to go in this direction, and it will come to the natural position somewhere here, but it will not stop because it has gained some velocity. It will further move, and it will further move, and let us say it moves and it reaches somewhere here, and if it reaches here, the spring will further elongate. So this is spring and the mass is here, and the spring will further elongate. So this spring has elongated. So this was the natural position, but now from the natural position this block has elongated the spring, and let's say this elongation is by. So we have to find what is the value of X so that this block just starts moving. They say this just leaves off the wall with velocity v, and this just reaches here, and that means this velocity will also be 0. So at the end both block will have 0 velocities. Now let us try to find how will you solve this problem. So there are two things you have to apply. First you have to apply energy conservation, and then you have to apply minimum amount of stretching so that block A will just leave or just will break off the friction. So let us solve this problem, pause this video and write two equations. Okay, I hope you have written these two equations. So let us first write energy conservation equation. So equation of energy conservation. So what you will have in this case, so the total initial energy is how much? So this spring has basically compressed by amount x. So this means this spring has some energy, some potential energy, and this spring energy is nothing but half k x square. So this is the energy. Now this is the initial situation, and this is the final situation. So where all this energy has gone? So some part of this energy has gone to elongate this spring, and this elongation is by. So I can say initial energy is equals to half k by s square. Some part of energy is stored in the spring, and some part has basically gone to against the friction, because this block has moved this distance and then this distance. So this block has basically moved x plus y distance, and during this motion what is happening, there is a friction. So on this block there is a friction that will act in this direction. What will the magnitude? Normal reaction will be n, and downward force will be mg. So n is equals to mg, and in this case mass of block is 2 kg, or I can simply write mb times z. So this force is mu times mb times z. So what is the work done by the friction? So this work will be force times displacement, that is mu times mb times z. This is the force, and displacement is x plus y. So the total energy initially we have this energy. This energy has gone to do some work against the friction, and this is this amount, and it has gone to a stored in the spring, and this is this amount. So now we have one equation. From where you will get the second equation? Because you have two unknown x and y. The second equation you will get because this block has to lift, or you can say this block has to move. So there is a friction. So this block will move only if this friction is broken. And to break this friction, what is the magnitude of this friction force? The magnitude will be again mu times ma times z. So this force, that is this time this is k by, because a string has extra elongation of by. So mu times maz must be equals to k by, then only this will break. So from here, so this is my second equation, I can solve for by. So by is nothing but mu maz divided by k. Mu is 0.5, mass is 2 kg, and g is 10, and k is given, that is 1000. So by in this case is basically 0.01 meter. So this is coming from equation number 2. So now if I plug the value of by in equation 1, so we can say, so from equation 1 we can write half kx square, k is 1000, and x we have to calculate, and half k is again 1000, and by we have already calculated, this is 0.01, and mu is 0.5, mb is 2, and g is 10. X we have to find out, and y is 0.01. So now we have to solve for x. So this is a quadratic, so this is 500, x square is equals to 500 times 10 to the power minus 4 plus, this will be 1, so 0.5 into 2, 1, and then 10. So this is 10x plus 0.1. So 500x square plus this will be 0.05 and this is 0.1 plus 10x. So this is equal to sign here. Now we can solve for x. So this will be 500x square minus 10x and minus 0.15 is equals to 0. So we have a quadratic equation. So x will be minus b, that is plus 10, plus minus b square, that is 100, plus minus b square minus 4 is c. So 4 times a times c, this will be 300, and divided by 2 times a is 500. Negative sign has no meaning because x cannot be negative, it's a physical quantity. So considering the positive root, we will have 10 plus 20 divided by 1000. So this will be 30 divided by 1000. So this is equals to 0.03 meter. So you have to basically stretch this string, basically compress this spring by an amount of 0.03 meter, that is 3 centimeter. Then only block A will leave the wall. Now question for you. What will happen if someone basically compresses the ball with greater than 0.03 meter? Let's say if someone compresses the ball with the spring with 0.05 meter, what will happen in that case? Will the block A and block B will have some velocity? Will they have equal velocity? What will be that velocity? What about the friction forces, work done against the friction forces? So let us discuss all this in the comment box, and I will see you in the next video. So if you like my videos, please share with your friends and subscribe to my channel. Thank you.